So industries that have been interested in our work, they've been of two types that correspond to the two types of research areas that I've described. One type that has become especially interested in our work is as these deep neural networks that are modeled off of these deep networks that I've described in the brain, as these simulated deep neural networks have been shown to be so good at computer vision tasks, to be at the cutting edge of what machines can do, many companies have gotten interested in building such networks for a whole range of applications. And so they're very much interested in what does our lab and others know about the latest improvements to deep neural networks that they might be able to harvest to apply to their own applications. And some of the most cutting edge industries are interested in partnering with us to being able to develop the next generation of deep neural networks that can perhaps be even more brain-like, not only in the way they process, but in the way they learn about the visual world. So learning is an area, learning to build such deep neural networks is an area that the machine systems are still far behind what we think the brain is able to do, to essentially set up the final state of the neural network. And so that's an area of open research that some of the most cutting-edge companies are interested in. What can we learn about the brain? So that's one area where I see where we've had industry contacts already and industry interest going forward. Another area where we've had a little bit of interest from industry, and I think will grow, is again as we understand to be able to inject percepts. Companies have been interested in that in a number of ways, and I suspect that as that technology improves in our understanding of the brain, that we'll see more interest in those kind of application areas. It's still too early to think about doing these things in humans directly, but in a 5 to 10 year time frame that will become more and more possible depending on the pace of our research and others that contribute in this area. So any domain in which visual data are used to analyze the world and make judgments that we could imagine these algorithms applying. The obvious ones are things like medical imaging, to be able to say this is a tumor, this is not a tumor, that's pathology, this is not pathology. Security, is this person belong or not? Face recognition. You're already seeing these kind of algorithms being deployed on devices. As they get mature to be able to understand not just visual data, but be able to learn from any type of data, they'll be deployed in ways that are even beyond what our evolutionary system had given us. So they might be able to process, for instance, the pattern of traffic data right now and predict what's going to happen in the next moment, or take a large picture view of how the traffic is going and going to predict how you should make a route through town. That's a little bit speculative, but I'm saying that these algorithms, as we understand how to make them learn better, they don't have to be restricted to the sensor data of a camera. They could be applied to other sensor data. Of course, we're just working on kind of what's called the first initial estimate of what's out there in the world. More newer work that starts to be outside of what my lab is doing at the moment will have to sort of expand into areas of how you do start to manipulate the object tokens that you extract from the world to do higher level cognition, to do more advanced artificial intelligence, if you will. But the most immediate applications are going to be anything that involves an image or a movie and extracting immediate content of what's out there in the world. And I think you can think that the applications are essentially boundless, and it's just a matter of how good these systems can get and how human we'd like them to be versus just pure good. And that's an interesting question. And what would you like your phone to make the same mistakes that you do when you try to recognize someone, for instance? So I also am the department head of brain and cognitive sciences, and there are many of us in the department that see one of our primary goals is, as we understand the brain, we should be able to build systems that emulate the brain and therefore able to build next generation intelligence. And so today's science we think of as tomorrow's engineering. And some of us in the department that have this interest have come together to start to collaborate and work with companies that see that vision, and some of those companies are starting to fund some of our research because they believe that as we understand those things, that we will be able to, again, achieve that vision of building even better systems, not just for problems like vision, other sensory problems like audition or language processing. And because, again, the brain is the best model we have of what is intelligence, we see that that future is quite bright. And it's been very inspiring because there have been these successes recently where ideas from the brain have now influenced the best machine vision systems that we imagine that's only going to get bigger. And so we do have active collaborations where we know this isn't going to be solved by one lab. The brain is a very complicated structure. Building an artificial intelligent machine would be just as complicated. And so these are what I see as a natural collaboration between what would be typically computer science and engineering with brain science, and really we're working on two sides of the same problem. If we really wanted to build an artificial system that works as well as us, would require in some sense us understanding ourselves that well, which is the mission of our entire department. So these are really two sides of the same coin, are synergistic with our goals of building, understanding the brain, are synergistic with the idea of building better artificial intelligence systems. And some companies that are very forward-looking have approached us with that interest, and we hope to do more of that.